relevance. Hey, for it being tutoring, 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 tutormemath.net. For it being tutoring, for it being tutoring.
Hello ladies and gentlemen, this is Mr. Witt with Fort Bend Tutoring, and today's tutorial is going to be about solving rational equations. Let's just dig right on in. If you have fractions in your equation, you have a rational equation that you're dealing with, and the bottom line is none of us wants to deal with it. No, we don't, but we do know how to deal with it. So let's go ahead and dig right in. What you want to do, ladies and gentlemen, is multiply each and every term by the common denominator. That is how you eliminate all the ratios, aka fractions, from your equation, and that's exactly the way I like to do it. Okay, so as I read this first problem, 3 over 4x equals to 5 over 2x minus 7/4. Too many fractions, so let's get rid of them. The common denominator for 4x, 2x, and 4 is 4x. So I'm going to multiply each and every term by 4x. I'll have 4x times 3 over 4x, which equals to 4x times 5 over 2x minus 4x times 7/4. All right, so this is what I have thus far. I found that my lowest common denominator would be 4x, and I'm multiplying each and every term in the equation by that LCD. In this case, it's 4x. Now, if you need help with finding the lowest common denominator, ladies and gentlemen, check out our video called Finding the Lowest Common Denominator. Okay, I'll put a link right here. So check that out if you're having trouble. Then the next step is to simplify. Okay, so in simplifying this, my 4x's will cancel out in that first term, so I'm going to bring down a 3. This is going to equal to the 2x going into 4x twice, so then multiply after that. So 2 times 5 gives me 10, minus, here the 4's will cancel out, and so x times 7 will give me 7x. And remember, that term was negative, which is why you end up with a negative 7x here in the equation. From this point, all you got to do is solve the equation. Look how much simpler this equation is compared to the original. Oh, does that not make you feel better? It makes me feel wonderful. So I'm going to go ahead and solve for x now. So I'll be subtracting 10 to both sides, like so. And I'll bring down a negative 7, which equals to negative 7x. And then divide both sides by negative 7. And so that means that x equals to 1, ladies and gentlemen. Maybe. Now, why do I say maybe? It's because we started out with an equation that had variables in the denominator. Anytime you have variables in the denominator, ladies and gentlemen, you may end up with extraneous solutions. Well, what is an extraneous solution? It means that you solved a problem correctly. However, because of the domain of the original function, of the original equation, you cannot use that value of x. So, in other words, to sum it up, you're just trying to avoid values of x that will make a 0 in the denominator. That's what you have to be aware of, okay? Because none of your fractions can ever have 0 in the denominator, because that'll make it undefined. So anytime you end up with a solution, all right, where you're solving for x and it happens to make the original denominator any denominator, just one of them will do. If it makes any denominator undefined, then you don't even mention it. But turns out that x equaling to 1 is a-okay, because plugging in 1 into the denominators of these fractions will not generate a 0 in the denominator. So we're good. We don't have any extraneous solutions in this problem, so that means that your answer is 1, and I'm going to put a box around it. That's right, like my boxes around my answers. All right, and now let's move on to the next problem, okay? Okay, in problem number 2 here, we have 2 over 3x plus 1 equals to 1 over x minus 6x over 3x plus 1. Well, what I know, ladies and gentlemen, is that I see fractions again and I hate it. So I'm going to get rid of those fractions by multiplying each and every term by the common denominator, which will be the product of all of our factors here. We have a factor that's 3x plus 1, and we also have a factor that's x. So your LCD, your lowest common denominator, is going to be x times 3x plus 1. And I'm going to multiply that to each and every term. That's right. And it's going to look just like this. That's right, multiplying each and every term by the common denominator of x times 3x plus 1. All right, and then I'll have minus x times 3x plus 1 times 6x over 3x plus 1. All right, so something like that, okay? Something like that. Let's simplify this. So in the first term here, left side of the equal sign, my 3x plus 1s will cancel out. What's left over is x times 2. So I'll have 2x. This equals 2. Over here, that first term on the right side of the equal sign, the x's will cancel out. And 3x plus 1 times 1 is 3x plus 1. Yep. Then the last term, okay, which is going to be negative, by the way, we'll have the 3x plus 1s cancel out. So x times 6x is going to be 6x squared, okay? And that's going to be our equation after we get rid of all of those nasty denominators, all right? So now what I'll do, because this appears to be quadratic in nature because the highest exponent is 2, we're going to set this equal to 0. Set it equal to 0. And I'll do that by adding 6x squared to both sides. I'm going to subtract 3x to both sides, and I'm also going to subtract 1 to both sides. Yep, just like that. Okay, so on the right side, all of this just cancels out. Goodbye. And I'll be bringing down 6x squared minus x minus 1, which equals 0. Okay, and we got that by adding the 6x squared to both sides, so that 6x squared comes down. Combining positive 2x and negative 3x gives us a negative x, and then we just simply bring down that negative 1, and we set it equal to 0. So let's go ahead and take this to the next page, shall we? Now that we have our 6x squared minus x minus 1 equal to 0 here, you're going to want to factor that. So we're going to factor this trinomial, and if you need help factoring trinomials like this, check out our Factoring Quadratic Trinomials Part 2 lesson, because it has examples just like that. I'll put a link right down here for you, okay? So check that out. So factoring this out, I'm going to end up with x minus 3 times x plus 2 equals 0. I'm going to divide both of these numbers by 6 and simplify. This gives me x minus 1/2 times x plus 1/3 equals 0. All right, continuing to factor, I end up with 2x minus 1 times 3x plus 1 equals 0, and that's the trinomial factored. Once we have it factored, ladies and gentlemen, go ahead and set each factor equal to 0 and solve for x. So I'll have 2x minus 1 equal to 0, as well as 3x plus 1 equal to 0, and then solving for x in each equation. I'll then bring down 2x, which equals to 1, then dividing both sides by 2, I end up with a potential answer that is 1/2. All right, and I say potential because this value may make my original equation undefined. Then I'll solve for the second equation by subtracting 1 on both sides, and I end up with 3x equals to negative 1. Dividing both sides by 3, I end up with a potential result of negative 1/3. So what we want to do with both of these solutions is go back and check our original equation to see if either of those solutions will make any of these fractions undefined. So notice that my answer of 1/2 is not going to make any of the denominators undefined. However, the negative 1/3, when placed into either of these denominators, will generate 0 in the denominator. So I can't use it. It's extraneous. So, going back to our solutions, the 1/2 is good to go, all right? That's our solution. However, the negative 1/3 is extraneous, and unless your teacher or textbook asks specifically for an extraneous solution, you don't even mention it, okay? It's not even worth talking about because you can't use it in the original equation. So the only answer is 1/2. That's it. I got a box around my answer, and that's it. Okay, now be careful about your extraneous solutions because sometimes when you get multiple solutions, one of them works, none of them works, or all of them work. So you don't even know how many of the solutions is going to work. So make sure that you go back and you try it at the beginning. You can also be aware of what numbers you need to avoid by finding the domain of the original function. And we have a video on finding the domain. And once again, I'll put a link right down here so you can check that video out as well. And that will give you a heads up on which numbers will be undefined in your original equation. All right, done. So let's continue on now. In problem number 3, we have x minus 4 over x plus 6 equals to 2x plus 3 divided by 2x minus 1. Anytime you have a fraction set equal to another fraction, ladies and gentlemen, that is a proportion. And when you have a proportion, you can use the extremes means method, aka you can just cross multiply, and that's exactly what I'm going to do. So in cross multiplying this like so, I end up with x minus 4 times 2x minus 1 equals to x plus 6 times 2x plus 3. Okay? From this point, go ahead and multiply everything out. So that's right, you're going to multiply these binomials, and that means I'm going to use the distributive property, my favorite property, and I'm about to get my arrows popping. Okay? So here we go with my arrows popping over here, like so. I'm going to get my arrows popping over here too. There you go, you get some, you get some. There you go, you get some. So then multiplying this out, I have x times 2x, which is 2x squared. And then x times negative 1 is negative x. Negative 4 times 2x is negative 8x. Negative 4 times negative 1 is a positive 4. And then multiplying on the right side of the equal sign, we have x times 2x, which is 2x squared. X times 3 is 3x. 6 times 2x is 12x. And then 6 times 3 gives me 18. Once I have this, ladies and gentlemen, I'm going to be combining like terms. So I have 2x squared minus 9x plus 4 equals to 2x squared plus 15x plus 18. All right. So I'm going to subtract 2x squared to both sides of the equal sign. All right. And that means that the 2x squared is going to cancel out altogether. Bringing down the negative 9x plus 4, which is equal to 15x plus 18, by the way. We'll solve for x by adding 9x to both sides, and if you'll permit, I'll go ahead and subtract 18 to both sides at the same time. All right. So my 9x's will cancel out, 18's will cancel out. I end up with negative 14, which equals to 24x, and then, oh yes, I'll be dividing both sides by 24. Yep. But my potential solution, I'll need to simplify this fraction. So reducing 14/24 by 2, you'll end up with negative 7/12. All right. So if we look at our original equation here, plugging in negative 7/12 into either one of our original denominators will not generate a 0 in the denominator. Therefore, our answer here, it's negative 7/12. That's it. I'm going to box it. All right. So I'm boxing it up, and that's it. Done. Negative 7/12 is the answer. All right, in our next problem, problem number 4, we have 1 over x plus 4 plus x over x minus 4 equals a negative 8 over x squared minus 16. So what you want to do in a problem like this is you want to be aware of all of your factors at all times, especially when you're trying to find the lowest common denominator. So I'm going to start by factoring this difference of squares here, which is x plus 4 times x minus 4. Now that I have that factored, I now know that my LCD is just this, because it's the product of all of the factors that I have in my equation. It's x plus 4 times x minus 4, and that is what I'm going to multiply each and every term by. X plus 4 times x minus 4 times that first term, which is 1 over x plus 4. Then I'm going to have plus x plus 4 times x minus 4 times my second term, which is x minus 4. All right. This is going to be equal to the LCD of x plus 4 times x minus 4 times the factored form of negative 8 over x plus 4 times x minus 4. All right. Just like that. So next what we'll do is we will simplify this equation now. In the first term, the x plus 4's will cancel out, and x minus 4 times 1, yeah, that's just x minus 4, okay? This is going to be plus. In the second term, what happens is the x minus 4's will cancel out, so you'll end up with x plus 4 times x, and just take your time on that. Just write it as x times x plus 4 for now, okay? Then this equals to, in our last term here, on that term on the right side of the equal sign, the x plus 4's will cancel out, the x minus 4's will cancel out, and I'm just left with negative 8. All right. So once again, I have a more appealing, visually appealing equation. Yeah, I do. So that means I'm going to go ahead and distribute now. Okay, so I'll be distributing, getting my arrows popping here, okay? Getting my arrows popping, and I end up with x minus 4 plus x squared plus 4x, which equals to negative 8, like so. All right, next we'll be combining our like terms, and I have x squared plus 5x minus 4 equals to negative 8. So then I'll add 8 to both sides here. okay, and end up with the following. I'll have x squared plus 5x plus 4 equals 0. Factoring this trinomial, you'll have x plus 4 times x plus 1 equals 0. Set each factor equal to 0 using the zero factor property, and you'll have x plus 4 equal to 0 and x plus 1 equal to 0. And then, solving for x, I'll subtract 4 to both sides here, and x equals to negative 4. Subtracting 1 to both sides, you'll find that the second equation you have x equals to negative 1. So negative 4 and negative 1 are your potential solutions, but they may be extraneous. You don't know. Let's go ahead and plug them into the original equation to see. Looking at your original equation, plugging in negative 4 into this denominator, or this one for that matter, you'll end up with 0 in the denominator. So that means that negative 4 is an extraneous solution. Plugging in negative 1, however, you will not end up with 0 in any of the denominators, which means that negative 1 is your solution. And that's it, ladies and gentlemen. Negative 1 is the solution to problem number 4. Let's go ahead and box it up. So that means that negative 4 is no good because it's extraneous. However, negative 1 does work. So negative 1 is the solution, the sole solution to problem number 4. All right, let's move on to the next problem. In problem number 5, we have 1 over y minus 1 plus 5/12 equals to negative 2 divided by 3y minus 3. Well, you can factor out a 3, and then we can show that this is the same as 3 times y minus 1. From here, we can look at the coefficients of 3 and 12 and see that our LCD would need to include 12 as a coefficient as well as the factor y minus 1. In other words, your LCD is 12 times y minus 1. So that's what I'll be multiplying each and every term by. All right, so I'm going to go ahead and simplify this by showing that 12 times y minus 1 is going to be multiplied times the entire equation here. And that's going to be times that 1 over y minus 1 plus 5/12, which equals to negative 2 over 3 times y minus 1. All right, so this is to show that my LCD of 12 times y minus 1 will multiply times each and every term in the equation. All right, and normally, to be honest with you, I would show that I'm multiplying this 12 times y minus 1 times each and every term individually, but since I'm short on space here, I'm just going to condense it this way. So we're going to get our arrows popping here, okay? And I'm going to show that I'm going to multiply each and every term times the LCD of 12 times y minus 1. So this is what's going to happen here. When I multiply 12 times y minus 1 times this first term of 1 over y minus 1, the y minus 1s are going to cancel out to leave me with 12 times 1, which is 12. All right? Then this next term will be positive. Multiplying 12 times y minus 1 times 5/12, my 12s will cancel out and leave me with 5 times the quantity of y minus 1. All right, this is going to then equal to 12 times y minus 1 times negative 2 over 3 times the quantity of y minus 1. My y minus 1s will cancel out, and not only that, 3 goes into 12 4 times, and then 4 times negative 2, okay, that's going to give me negative 8. So when simplifying the product of 12 times y minus 1 times negative 2 over 3 times y minus 1, yeah, the y minus 1s cancel out, 3 goes into 12 4 times, and then you multiply that 4 times your numerator's negative 2 to end up with negative 8. I said all that to show that this equation, simplified without any fractions, is relatively easy now, right? So all I got to do is get my arrows popping and multiply everything inside the parentheses times 5. Well, I can do that. I'm going to go ahead and bring down this 12 plus 5 times y is 5y, and then 5 times negative 1 gives me negative 5, and this is going to equal to negative 8, like that. Now, let's go ahead and combine those like terms on the left side of that equal sign. We have 12 minus 5, and that'll combine and give me a positive 7. And I'm going to write it like this. I'm going to say that I have 5y plus 7 equals to, I don't like that 7. I hate that 7. Plus 7 equals to negative 8 here. Then I'm going to subtract 7 to both sides. Oh, yes, I will. Oh, yes, I will. And then I'll bring down 5y, which equals to negative 15. Just like that. All right, we'll be dividing both sides of this equation by 5 now. All right, and so when I divide both sides by 5, I'll end up with y equals to negative 3 potentially, all right? This may or may not be the answer. You need to check to see if this is an extraneous solution. So go ahead and take that -3 and look at our original problem here. And let's see if -3 will create a 0 in any of these denominators. So plugging in -3 into the first denominator, that won't give us a 0. And plugging in -3 into this last denominator won't give us an undefined situation. So that means that it's good. We can keep it. It's good to go. In other words, that's the solution. All right, so let's go ahead and put a red box around my answer here, because y equals to -3 is it. That's my solution. Red boxing it. All right, there you go. Y equals to -3 for problem number 5. Let's move on. All right, in problem number 6 here, we have 1 over y plus 2 plus 3 over y plus 7 equals to 5 over the quantity y squared plus 9y plus 14. And what you want to do here is you want to factor the trinomial. Yeah, we don't want to deal with this trinomial the way it is. So if I were to factor this out, this would become y plus 7 times y plus 2. So the factorization of this quadratic trinomial is y plus 7 times y plus 2. All right, and that happens to be the other two factors that you'll find in our equation, which means that's the LCD. Yeah, that's what I need to multiply each and every term by. Y plus 7 times y plus 2. I'll have my quantity of y plus 7 times y plus 2, and I'm going to show here that the entire equation is going to be multiplied by that LCD. And I'm going to use this simplified form here so that things won't get too messy. All right, so and I'm going to use the factored form of that denominator as well, that y plus 7 times y plus 2. All right, so here we have it. Okay, now we will be distributing this LCD, that y plus 7 times y plus 2, to each and every term in our equation. Multiplying y plus 7 times y plus 2 times 1 over y plus 2. Yeah, those y plus 2's are going to cancel out, and 1 times y plus 7 is y plus 7. Just like that. All right, let's go ahead and center that so you can see it. There you go. Now you can see it better. Then multiplying y plus 7 times y plus 2 times 3 over y plus 7, the y plus 7's will cancel out, and that leaves me with a positive 3 times the leftover quantity of y plus 2. Just like that. This is going to now equal to, now multiplying y plus 7 times y plus 2 times 5 over y plus 7 times y plus 2. Yeah, the denominator, y plus 7 times y plus 2, will cancel out. All right, and that's just going to leave me with 5. Yeah, all of those factors will cancel out of that. Because remember, when you're multiplying by your LCD, it's like having it over 1. So multiplying this ratio times that ratio, yeah, your y plus 7's and y plus 2's will cancel out to leave you with that 5. And that's it. All right, so this is what we have to work with. And lo and behold, we now have a distributive property problem. So I get to get my arrows popping, ladies and gentlemen. That's right. So I'll be bringing down y plus 7 plus 3 times y, which is 3y, plus 3 times 2, which is 6, and that now equals to 5, like so. Combining our like terms here, we'll have y plus 3y, that gives us 4y. Then 7 plus 6 is always 13. I'm bringing that down now, and also bringing down the number 5. From here, I'll be subtracting 13 to both sides. You got it. Just like that. Okay. Next, I'll be bringing down my 4y, and this equals to -8. So once I have this, I will be dividing both sides by 4. You got it. And y could potentially equal to -2. I don't know yet. I got to plug it back into the original problem to see if that's going to be an extraneous solution or not. So going back up to my original equation. Yeah, here we are. Okay. If I were to plug in -2 into this first denominator, that will give me 0 in the denominator. I can't have 0 in the denominator, ladies and gentlemen. You can't have it. It's undefined. So therefore, our solution, -2, is an extraneous solution, which means we cannot include that in our answer. So it's no good. That's right. So if you don't have any other solutions to offer as a solution to your original equation, that means that the solution is the null set. In other words, no solution. That's it. There are no solutions to this problem. So I'm going to red box this because that is the result. That's it. It's undefined. There are no solutions to this problem. No solution. That's it. All right. Just like so, ladies and gentlemen. That's it. No solution is the result of problem number 6. All right, ladies and gentlemen, and that's going to do it for solving rational equations with Mr. Witt and Fort Bend Tutoring. As always, please rate, comment, and please subscribe. And if you're able, please donate, as that helps us bring you more free math tutorials from Fort Bend Tutoring. Peace.
So what you waiting on? Everything is online. Just hit the website, they even got FaceTime. Subscribe to the YouTube, request the video. Watch your math skills go from alright to incredible. They got math, got algebra, got geometry. Pre-calc, calculus, can't forget trigonometry.